Hello everyone. Welcome back to this channel. Today, logarithms are more important than ever. They bridge algebra, geometry, information theory, and modern computation. A single idea from 1614 continues to shape the world. In computing, logarithms measure complexity, compress data, and stabilize algorithms. In machine learning, they appear in loss functions, softmax, entropy, and neural network optimization. The story of logarithms is a story of human ingenuity. A simple insight, turning multiplication into addition, transformed science, engineering, and technology. From predicting planetary motion to training neural networks, logarithms remain one of the most powerful tools in mathematics. Starting today, we're going to use this powerful tool, the logarithm, to solve a series of problems. In this video, we'll explore a logarithm problem from the 1983 American Invitational Mathematics Examination. In this problem, the real numbers x, y, and z are all greater than 1, and w is a positive real number. They satisfy the logarithmic equations shown on the screen. Our goal is to find the value of log base z of w. We'll solve this problem using 3 different methods. Although the approaches are different, each one reveals a deeper insight into how to think about and solve logarithmic equations. Let's walk through these 3 methods and see, step by step, how they lead us to the solution. Method 1 uses the reciprocal rule of logarithms. The core idea is simple: flip and add. Now, let's walk through the details step by step. For method 1, the core idea is flip and add. The key insight is this: since the argument w is the same in all the logarithms, taking reciprocals turns w into the common base. The mathematical strategy is to take the reciprocal of each logarithm and then add the resulting fractions. This method is extremely efficient. In fact, it's often the fastest approach for competition math problems where the argument remains fixed. Method 2 uses the change of base formula for logarithms, converting everything to base z. The core idea here is algebraic substitution. Now, let's walk through the details step by step. For method 2, the core idea is algebraic substitution. The key insight is this: by converting all logarithms to base z, the base we ultimately care about, we turn the problem into a straightforward algebraic equation. The mathematical strategy is simple. Solve a linear equation that emerges from the substitution. This method is moderately efficient. It works reliably, but it requires more algebraic work, such as clearing denominators and simplifying expressions. Method 3 uses exponential form. Starting from the definition of a logarithm, we rewrite each logarithmic equation in exponential form, which lets us apply simple power rules. The core idea here is, go back to the definition of a logarithm. Now, let's walk through the details step by step. For method 3, the core idea is, definition of a logarithm. The key insight is this. Logarithms are simply exponents in disguise. By converting each logarithmic expression into exponential form, we can apply basic power rules with ease. The mathematical strategy is straightforward. Equate the exponents. This method is extremely efficient and often feels very intuitive for students who prefer arithmetic-based reasoning over abstract logarithm rules. In summary, the three methods reveal specific truths about solving logarithmic problems. Key takeaway 1. Identify the anchor. In this problem, W is the anchor. It appears in every term. Method 1 makes W the base of the logarithm. Method 3 makes W the base of the exponent. Insight. Whenever possible, rewrite your expression so the constant element becomes the base. Key takeaway 2. Logs and exponents are the same idea. Method 1 and Method 3 are mathematically identical. One uses logarithms, the other uses exponents. They're just two languages describing the same operation. Key takeaway 3. Assign a variable. Method 2 shows the power of substitution. Letting a complicated expression equals a single variable turns a messy log equation into simple algebra. Alright, it's time to wrap up. What do you think about the problem, the solution, the three methods, and the key insights? Leave a comment below. And don't forget to like, share, and subscribe for more fun math problems. See you next time, and thank you for watching.